Let's discuss the question number 22 from test series 4, and this is from thermodynamics. They applied thermodynamics, basically the refrigeration part. Okay, that's so entire thing comes in thermodynamics. So what is given is a condenser of a refrigeration unit resets heat at a rate of 120 kilowatt, and so let me just write down the Q of condenser, which is heat resetted is 120 kilowatts, and while its compressor consumes a power of 30 kilowatts. So for that is the power input to the compressor, which is 30 kilowatts. Okay, so COP is what is asked. Okay, so let's just draw how a typical refrigerator works. So this is my evaporator, and then the evaporator is something which takes heat from your whatever hot items you keep it in the fridge. So that heat is taken by this device, evaporator. Then you have the compressor. I should basically draw in this way. You have the compressor where you supply which is run by a motor, electric motor, and so the power input is basically given, which is W compressor. Now this is how the flow, and then you have the condenser, which basically resets heat to the atmosphere, and then a small expander is given, okay, which brings the fluid back to its normal state. Okay, so now evaporator is something which absorbs the heat from the hot items which you keep in the fridge. Okay, so now using the first law for this process, one can always write integral dq is integral dw. So whatever the heat additions, the net heat addition has to be equal to the net work output or net work by the system in a cyclic process. So this circle denotes a cyclic process. So here let's the heat that is absorbed by this refrigerant unit is taken as positive, so Q absorb, and heat resetted out is only Q condenser, so minus Q condenser is equal to the work that is output. So work that is output, okay, but here the work is the work is input, so I'll write minus W compressor. Okay, so Q absorb is something I need to find out, minus condenser is heat that is radiated out, minus compressor, the work done is on the system. Okay, so it's minus 30, so Q absorb has to be 90 kilowatts. Okay, so now COP for a refrigerator unit is defined as the desired effect by the work input. Okay, so desired effect is I want my how much I'm interested in this quantity, how much of heat it can take from my hot items whatever I keep. So that is Q absorb is the desired effect, and work input is whatever I supply to the compressor. Okay, so that I have found out Q absorb to be 90, work I have given is 30 kilowatts, so COP comes out to be 3. The answer is D. Thank you.